This is TWIS. This Week in Science, episode number 854, recorded on Wednesday, December 8th, 2021. What time does science say to eat? Hey there, I'm Dr. Kiki, and tonight on the show, we will fill your head with food, sex, and unconfirmable results. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer, disclaimer, disclaimer. You can only go so far in this world before you find yourself at a door. You unlock this door with the key of education. Beyond it is another dimension. A dimension of sound reasoning, a dimension of insights, a dimension of mindful observation. A place to contemplate the vastness of space and the timelessness of infinity. You are now traveling through a wondrous land, both science and substance, of things and ideas whose boundaries are that of imagination. Signpost up ahead. You've just crossed over into This Week in Science. Coming up next.
I've got the kind of mind I can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We are back again to talk about the science. We have science stories. Justin, welcome back.
Thank you.
We hope that you are having a lovely honeymoon
Yes. Absolutely.
and that you got many well wishes and congratulations.
Yeah, people
over
were
the
like,
last week.
hey, way to finally stop being single all the time.
There you go. Yeah.
Pretty great.
Way to do it. You figured it out.
They were like, about time, mostly was the response.
Oh, people. It's about time for the science, though. I have stories about pollution correlations, primate cavities, and proteins to fight aging.
Ooh, those are the good kind.
They're the good kind.
What do I got?
What do you have, Justin?
I got somewhere in here I wrote down a list. Okay, I've got just good news. Melting ice edition.
Oh, yay.
Yeah. I have unrepeatable science experiments. Unreproducible. Bare feet of Tanzania. And why every prison should be a college.
Oh, interesting. Very interesting. Blair, what is in the animal corner?
Oh, yes, the animal corner. I have a story about bird feathers and another about orbiting spiders. And then outside of the corner, I have a story about smoked salmon, the food, and also chewing gum for COVID.
And that's not like a fundraiser where it's like,
No.
How many pieces of chewing gum can you stuff in your mouth to make money for?
No, not Violet.
How long can you chew the same piece of gum? Yes.
Oh, is this going to be like all the previously chewed gum, like on banisters, under tables, and on the subways, whatever?
Oh, yeah, to boost your immune system.
Full of COVID?
For sure, yeah.
No, don't touch it. Don't touch it. It's evil.
No, just wait till the COVID update. Well, I'll tell you all about it.
Okay.
Oh my gosh. Terrifying.
As we jump into the show, because that COVID update is coming in a little bit, as are all those stories, I do want to remind you that if you are not yet subscribed to the TWIS podcast, you can find This Week in Science on just about every podcast platform out there. We are also on YouTube and on Facebook and on Twitch for live streamed episodes. And you can find us as TWIS Science on Instagram, on Twitch, and on Twitter. We're out there. We're doing things. Spreading the science. We hope that you follow. Now, let's see if you can follow us down this winding trail of science breadcrumbs. Okay, let's talk about pollution correlations. Well, really, pollution and sex.
Gender?
Pollution,
No, sex.
sex, pollution, and the sex of children when they are born.
Right.
A study out this week in the PLOS Computational Sciences has found a connection, or computational biology, excuse me, has found a connection between pollution levels and changes in the birth sex ratio. This is just
In humans?
In humans. They looked at 150
goodness.
million people in the United States over 8 years, 9 million people in Sweden over 30 years, and we're trying to figure out what factors might be involved in the shifting sex ratios of males to females in human babies, because there is, even odds that you're going to have the XY or the XX chromosomes. There are other odds in there for other determinations, but for a general averaging, it's pretty much even odds that you're going to have males or females. And so researchers have been trying to figure out all these many societal, biological, environmental factors that could potentially be shifting the predominance to males over females, because they have seen a larger number of males being born than females over the years. So why is it happening? Why is it slightly skewed in that direction? Well, this massive look at this massive collection of data found a whole bunch of correlations, and they're really just trying to pull statistical significance out of this massive collection of data. And it could be said that they were digging for trends, that they were trend hunting. It's not really p hacking, but this could be on the level of similarity to some of the large GWAS, the genome-wide surveys that find statistical significance between different genes and biological factors that we've discovered are not really as amazing as we thought they were, because they were just kind of digging in these big piles of data for connections. So that said, they found connections between aluminum, chromium, mercury, and these are airborne and waterborne pollutants. They also found an opposite correlation with higher levels of lead in soil. More lead in the soil led to fewer male babies being born. But then they also looked at stressful events. Hurricane Katrina didn't have any effect on the sex ratios, but the Virginia Tech shooting in the United States did. It affected the numbers of males versus females. So you can look at some of these correlations and go, why would the Virginia Tech shooting versus Hurricane Katrina, and what are you talking about? And how is that going to have an effect? And there are a lot of things in there that there are correlational trends that it's like, it probably isn't anything at all. And thank goodness the researchers do say these are correlations, but maybe they point to a direction where real research should be done.
Nope.
Yeah, this one's tough for me. I think that it's in the life of a human outside of a lab, you can't. How can you possibly narrow this down to one thing? I don't think you can.
Yeah. I mean, so maybe these are, similar to the GWAS, to those genomic analyses and correlations. Maybe they have a small percentage influence. Maybe they have a small, it's pushing things over the edge just a little bit, but yeah.
Well,
so they need to study cells. They need to study mechanisms. They need to be looking deeper into it. But yeah, this was like digging in a mud puddle and going, oh, I found dirt at the bottom.
Yeah, so mechanism and all that stuff does come later, and you got to start with a correlative. You have to have a thing that makes you start zeroing in on something in the first place. And so correlative evidence for things, or correlative associations of things, is a great place to start looking for these things, like the lead in the soil versus the birth rate of males versus females, is something that might be interesting enough to look into. But I think they do a good job in a weird way of showing the limits of relying on that by using the hurricane affected a huge swath of an entire state of people. No effect.
No effect.
And then the umpteenth shooting at a school that year alone having this dramatic effect shows you that, like, well, you could have been possibly like, what was the topic on the John Oliver show this week? And how did that affect?
And how did that affect
the birth
things?
rate?
Yeah.
Oh, well, he talked about this subject, which is controversial, and the birth rate went this way. And then next week it was more jokes, and so they went the other way. So it shows the limits of using correlative at the same time.
I think so. Yeah.
That's why when you do these things, there has to be a level of previous knowledge brought to bear. So something like an exposure to a heavy metal in the soil might be something you might have to say, hey, we've seen different effects in other species with this. Now we're looking at the correlative between where this pollution exists and birth rates in humans. And we found a signal that we can then go and investigate versus just blanket looking for those p-value hacking values or whatever, looking for hits. You start to create them without previous knowledge. And then that's when they become less, I think, useful.
Yeah. But I think it's important for people to understand when they look at some of the headlines, like they're probably this week seeing headlines that say sex ratios at birth linked to pollutants. It's like, oh, which ones? How does that work? What's going on? Oh, pollution, bad. Yes, pollution is bad. It's not helpful for many things, but the word linked usually means there's a correlation. It doesn't usually imply some sort of mechanism or proof. And so it's a good way to critically view the headlines that you might look past before you go, oh, right, I know this. No.
Yeah, I think the word linked is used inappropriately, actually. I would say the fact that they're saying it's linked is inappropriate.
Right, is it? It's correlated. It's they found some things that look like, oh, they might go together. Yeah. Anyway, be on your lookout when you're looking out there at those headlines, everyone. Justin, what do you want to tell us about right now?
Oh, I've got just good news this week. Yeah. That's the news segment. It's designed to put a good science news story in your head, despite the subject matter maybe being something that's not as ideally suited for positive information, things that you would want to be thinking about. Just good news, melting ice edition. Simon Fraser University researchers looking into retreating glaciers in North America have found that loss of freshwater glaciers could produce more than 6,000 kilometers of potential new Pacific salmon habitat by the year 2100. So there's some 46,000 glaciers just between southern British Columbia and south central Alaska, and they're melting rather rapidly, it seems. Underneath them is bedrock, and they will, as these melts take place, they're going to create new tributaries, new rivers, new lake areas, and they're going to create a lot of salmon-friendly landscapes. So these are landscapes that are going to have fresh water, with access to the ocean. So the salmon are going to be able to find it, swim up there, lay eggs, reproduce. All the conditions they need for a salmon colony. This is quoting voice of Pittman, who's one of the researchers involved in looking at all this. It's a common misconception that all salmon return home to the streams they were born in. Most do, but many individuals will stray, migrating into new streams to spawn, and if conditions are favorable, the population can increase rapidly. So they have another example of something called the Stonefly Creek in Glacier Bay, Alaska. There were some glaciers that retreated back in the 70s, and these pink salmon, moved in to the retreated area and became a spawning ground. So potential good news for salmon habitats in some areas where there used to be glaciers. In other ice melting news, a new technique developed by McMaster University in Canada, samples DNA from ice core permafrost, which is good news because there is still permafrost to use this technology on at the moment, although rapidly melting. The technology has shown up just in time. They published in Nature Communications. The creatures present a 30,000-year DNA record of past environments from cored permafrost sediments extracted from the Klondike region in the Yukon. Researchers use DNA capture enrichment technology to observe fluctuating animal and plant communities at different time points. Very notably, they found the presence of both woolly mammoth and North American horses until as recently as 5,000 years ago. So that's
a lot more recently than we thought.
Yeah, it's about 6,000 years more current.
Yeah,
than our last run. Because that's around that 11,000 year time point is a bit of a bottleneck. I think when we lose the saber-tooth tiger and some other large fauna in North America. And it's not the horses and the mammoth went away too, but no, mammoth and horses. So this is quoting, who is this here? This is Tyler Murchie, who's a postdoctoral researcher at McMaster's Department of Anthropology and a lead author of the study. Now that we have these technologies, we realize how much life history information is stored in the permafrost. The amount of genetic data in permafrost is quite enormous and really allows for a scale of ecosystem and evolutionary reconstruction that is unparalleled with other methods to date. Which is really amazing if you think about it. Like all of the time we spend fossil hunting, we've got to find a thing that happens to be preserved well enough, arid enough, or buried enough situation for us to even find the evidence of it. Here's permafrost. There's frozen soil that's been there for 30,000 years. And they're able to use this technique to gather DNA out of the layers of the frozen soil and reconstruct from whence it had come.
Yeah, and I'm thinking, I mean, we've talked so much on the show about, ancient bacteria or fungi that could be thawed and potentially come back, spores that could once again become active and join the modern world and not have been seen for thousands of years. If that's possible, then why wouldn't DNA be just this DNA, these records of these other animals? You take one and one, and sometimes you don't put it together to make two. You need the scientists to lead you there.
This is Ross McPhee, the American Museum of Natural History, a co-author, says the horse that lived in the Yukon 5,000 years ago is directly related to the horse species we have today. Biologically, this makes the horse a native North American mammal, and it should be treated as such. So this is sort of an interesting thing, because we think of the horse as being introduced to North America.
Yeah.
But the horse that was introduced to North America was in North America not that long ago, 5,000 years ago.
Well, there's different types of horses on different continents, right? So I think that's the thing.
No. That's the other thing. That's not quite true. So the horses that propagated in Asia, with the Mongolian hordes, first horse riders, they were really dedicated horse riding people. Those horses used to move back and forth from North America to Northeast Asia whenever there were grasslands between the two. The Bering Strait was grasslands for a tremendous amount of time. And horses moved back and forth, and they'd get stuck on one side or the other, and then they would freeze again, and we'd be able to wander back and forth again. So this idea that we have horses on such disparate parts of the planet, actually, it's, if you move the map over those parts of the map, when you have the U.S. at one end and all of Europe is always shown on the other side of the map. And you can scooch that globe around, and it's all connected at some point.
This is probably part of a bigger conversation about native versus invasive species, and
Right.
where did it come from and when and how far back are you talking, and and
But it's,
at the
but it also shows
ecosystem
that-
level.
Yeah, it also shows that we've had this conversation before about reintroducing the mammoth because it was 10, 11,000 years since it's been in North America. Now it's only 5,000 years.
Only 5,000?
Getting closer.
That's not long. Okay, Blair, tell me a story.
Well, I want to talk about salmon, specifically Danish smoked salmon.
Yum.
Whoa.
Yes.
Delicious.
So this is a study from University of Copenhagen looking at smoked salmon, which is extremely popular in Danish shopping markets. Always. Everyone's eating smoked salmon. And the majority of smoked salmon in Denmark is sourced from Norwegian aquaculture farms. Conventionally farmed salmon from Norway, just like farm salmon here, has a questionable reputation. Everyone wants the wild-caught salmon, right? And we know here in the United States that the farmed salmon is not as good for the environment for a bunch of reasons. Salmon eat other fish, so the act of having to source food for salmon is not an environmentally friendly practice, not to mention because they're kind of in these confined and high population environments. They have to be pumped with vitamins and antibiotics and all sorts of other things. Also, they're often dyed. There's lots of things happening with farm salmon where if you're trying to be an environmentalist and maybe also if you're trying to show off in your grocery cart, you're going to buy the wild-caught salmon. The wild-caught salmon is also usually more expensive. So what University of Copenhagen wanted to do was to take 92 Danes and ask them to taste samples of conventional, organic, and wild-caught smoked salmon. The first round was a blind test in which the test subjects were uninformed what type of salmon they were tasting, and then in the second, they were informed as to what they were tasting. You guess what happened?
I'm going to imagine it was like the wine tasting where they had people taste which is the cheap and which was the expensive wine, and they really couldn't tell.
And they pick the $2 chuck, right, as the more expensive wine. That's exactly what happened. So in the blind test, the conventional and organic salmons won over the wild salmon. So the farm salmon did better. The wild salmon scored significantly lower than both of the farmed products. But once the test subjects were informed what they were eating, it completely changed. Among informed respondents, the conventional salmon placed last, wild salmon took second, and organic first. And so in this case, this seems to be a very specific bias that people want to say that the organic is the tastiest. This could be a larger issue that if you ask someone, does the organic produce taste better, they might tell you yes, but in a blind taste test, that may or may not be the case. And so part of this has to do with the perception that wild-caught salmon should taste better because it's better for the environment and it's more healthy. But the other thing that they wanted to bring up is that farm salmon is much easier to get and is cheaper. And so therefore, taste buds could be accustomed to farmed salmon.
Because that's what people usually eat.
Right. Another option is that the wild salmon has less flavor because it's leaner than the farmed salmon. So there could be a couple things going on here. I think it's an interesting thing to mention that it could be about kind of confirmation of familiarity. Of just, this is what I'm used to. This is what I grew up on. But I also think that this is a good reminder that often the food that's not as good for us tastes better.
It's hard not to find a smoked fish. That's the problem in Denmark. It's hard to find something that's not smoked.
Sure.
And I'm not a big fan.
Well, anyway, I think, so a couple takeaways from this. One being, if you want people to choose the more environmentally friendly option, label it.
Yeah. Because then
they're
people will choose based on the fact that they want to be environmentally friendly.
or healthier or whatever it is. So labels actually could benefit. Basically, the act of greenwashing could benefit the environment if used appropriately, which I think is funny.
Mhm.
But also, it's just a good reminder that what the thing that's healthier or cleaner or better doesn't always taste.
And you can't always tell the difference. You don't always make the right choice. Yeah.
And it might not be healthier. Hey, I've got an organic thing here. It tastes worse and is less healthy, but it's better for the planet. Like that's like a third real option right there. You have to admit at some point, like sometimes the thing with a lot of preservatives and additives that tore down part of a rainforest, it's a tastier snack.
It's not tastier once you say it like that, Justin. Nothing that tore down a rainforest is going to taste delicious. But when you're thinking of delicious things, have you ever thought about how those delicious how those delicious things affect your teeth? Ooh. And how, when you're going for the really delicious stuff that possibly has sugar in it, suddenly you're potentially prone to more cavities. Or if you're drinking something acidic, that maybe that's going to affect the enamel, the dentin and the enamel on your teeth, making you prone to more cavities. Have you ever thought about whether or not other primates get cavities too?
Yes, I have.
I'm gonna guess that I was gonna guess that you had, Blair.
Interesting. I can't think of a single time when I've seen another primate species brush its teeth.
Exactly. So Blair, have you as a zookeeper in a previous incarnation, did you ever brush a primate's teeth other than your own?
No. However, whenever we did a full workup, we would do a close tooth inspection to make sure. And sometimes, actually, a few times, a human dentist came out to work on primate teeth.
Oh, fascinating.
Yeah.
Did you, and this is going to be definitely anecdotal because you probably weren't looking for it, but could you say what different primates ate based on whether or not they got cavities? Were some primates more or less prone to cavities?
Ooh. No, I have no idea. I feel like carnivore teeth usually is grosser. Is that a thing?
They're grosser from the meat eating aspect, but some researchers just published
I'd go the other way around.
Yeah, they published a study of they looked at 11 different primate species, a bunch of different catarrhine primates, and looked to see what was going on in their teeth. So checked bacterial levels, looked for dental caries, looked for, I guess you don't call it weathering, but erosion, periodontal disease in the teeth. They looked at chimpanzees, western lowland gorillas, Klaus's gibbon, Hamadryas baboons, pig-tailed langurs, Japanese macaque, dense Mona monkey, blue monkey, mandrill, Raffles banded langur, and the Mentawai langur. All of the specimens were wild. So none of these were receiving zoo diets. These were all wild diets that they were eating. And while cavities have been seen in zoo primates because and we're feeding them whatever food seems good from the zookeeper perspective, wild animals are potentially out there getting their own food. And they found that out of the 11, I mean, they looked at a bunch of different teeth, but only 5 species had cavities that they could see in their front teeth, because, and it's in the front teeth the most because these animals do a practice of taking fruit and then squishing it in their front teeth and sucking the sugar out. And it is a dedicated practice of these animals. And so you would expect, because they're eating the sweet sweet fruits, getting the sugars and sucking them down, that they're potentially going to be doing more damage to their teeth. This practice is called wadging.
Mm-hmm.
They wadge these fruits in their mouth and suck out the liquid. So they determined that, yes, chimpanzees, gorillas, a bunch of these animals that tend to enjoy the sweeter fruits had cavities, whereas others that don't do this wadging behavior don't get, or they didn't have the cavities. So that in itself was very interesting, something new. But really, it's interesting to note that cavities are shared by many different species of animals. If they have teeth, they have the potential for getting cavities, but they don't always have dentists unless they're in the zoo. Interestingly, though, this particular study, they found more decayed teeth in female chimpanzees than male chimpanzees. They don't know why that was, but overall, their conclusion is that the cavities seem to be indicative, the patterns of the cavities themselves seem to be indicative of food processing behaviors and diet. So by looking at teeth of maybe trapped animals that you're sampling or of deceased animals that you've discovered, you can get insight into what they eat, how they eat, and their ecological behaviors. Justin, do you have another story? You want to reproduce this one?
All right, this next story is troubling, to say the least. 8 years ago, a team of researchers launched a project to carefully replicate influential, high-impact lab experiments in cancer research. They picked papers in major science journals like Cell, Science, Nature, between the years 2010 and 2012. All of the papers were preliminary research. So this is research on mice or in a lab dish type of a thing. These all were things that hinted at future therapeutic uses. Results in all of these studies no doubt had caveats of optimism embedded in phrases like, may one day lead to the foundations of a new path to open doors into novel therapies or approaches to advance the science of blah, 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 blah. They recreated 50 experiments, and there was a problem. About half of the claims could not be replicated. And actually, it may have been much, much worse than that, because while they're publishing about the 50 research experiments, only having about 50% reproducibility, there were actually about 200 experiments in 53 papers at the outset of their project. But there was insufficient information about how most of the experiments were done. So muddy and vague were the published papers in detailing experiments that only the 50 could be done with confidence. And even then, I think about 40%, third of those needed them to contact the researchers to get more information about reagents involved or techniques involved. Some of the researchers they contact listed as unhelpful. Some were more than unhelpful. 32% they listed as more than unhelpful, which is, you have to think is like, not helpful, it's just, I'm not going to help you. More than unhelpful. Sounds like they were upset that their research was
They're
being looked at.
actively unhelpful.
Actively.
Sending them bad data.
Yeah, something. So yeah, ultimately 50 replication experiments from 23 of the original papers were completed, generating data about the repeatability of a total of 158 effects reported in those papers. Replication effect sizes were 85% smaller on average than in the original findings. Only 46% of effects replicated successfully on more criteria than they had failed at. And original positive results were half as likely to replicate successfully, actually 40%. And then they had null results from the originals that replicated 80%. 20% of null results produced results when they hadn't before. Collectively, the evidence suggests opportunities to improve transparency, sharing, and the rigor of preclinical research. So this is again not these are not drugs that went to market that were being tested. Those have made it through many rounds of evidence and experiment and trials and all of that sort of thing. This is all preliminary stuff. This is quoting Marcia McNutt, who's the president of the National Academy of Sciences. There's little incentive for researchers to share methods and data so that others can verify the work. Researchers lose prestige if their results don't hold up to scrutiny, and there are built-in rewards for publishing discoveries. So there's pressure to publish, and I don't want you to look at how I did my science. I don't want you to make fun of me if I made a mistake, kind of a thing. That's not a good system. That's not a good system to be
and I imagine,
pipelining.
There's, it's not wanting to be made fun of, but it's also, maybe the data was transposed, or maybe there's something incorrectly entered because they, had a student entering instead of doing it themselves, or there were no quality control methods to make sure the data was entered correctly, or
fraud,
or there's outright fraud. Yeah,
when you're talking about 50%,
a lot, but it's the publisher perish pipeline is a real thing, and it is not created in a way that it benefits science, because this is the kind of stuff that comes out of it. People rush to get papers out. They don't make sure they've got the best data. It's like, oh, we did it. Okay, publish or do it again. And there's just not enough money to maintain the pipeline of let's do that experiment over again, and let's do it again, and let's make sure our methods are really rigorous. Sometimes it's labs running on a shoestring trying to get things done.
Daniel Smith in the chat room saying, or just bias seeping in, and that's 100% going to be part of this. You believe your experiment will reveal something important, and you run your experiment and you get a signal and you say, aha, this means XYZ. Therefore, so it could just be bias. It could be bad, some poor experiment setup. Part of it is just, it could be that people aren't sharing how they did the experiments in the first place.
Yeah.
So there was.
I love the pre-experiment open servers that researchers are using now, where researchers put their plan for their study out to be critiqued by members of the community, and their statistical methods, like basically all the logic for what they're going to do before they do the experiment. Mm-hmm. And so then the community can say, no, you need to change this statistical test, or this reagent isn't going to work. And so the process is transparent from the very beginning, but those are really just getting started at this point.
Yeah, this is, there was a couple things that they found here. Among the studies that did not hold up was one that found a certain gut bacteria was tied to colon cancer in humans. Another was for a type of drug that shrunk breast tumors in mice. A third was a mouse study of a potential prostate cancer drug. Didn't hold up, although that one apparently has been moving through and is in clinical trials right now. So some of this is going to be not being transparent, perhaps, about how you did an experiment. If you got a result that can't be replicated, is it because somebody didn't want to share how they did their experiment in the first place? And if so, the information that's out there, is that false information?
Yeah.
And is that then going to mislead others down the
wrong path?
So many
questions. It goes way back. Yeah.
This is the second major analysis by the Reproducibility Project, is what this is called. I think this is through the Center for Open Science who's doing this. In 2015, this is the group that found similar problems when they tried to repeat experiments that were in the psychology realm.
Yeah, and similar problems were found. And speaking of replication and what you do over and over again, something we do every night, hopefully many of us, sleep. I mean, it's hard to come by for some. And there are those of us who have shift work that keeps them awake all night long. And we've talked a lot on the show about how do you stay healthy when we know that there is a mismatch between the circadian rhythm of the normal 24-hour day with the sun coming up and wanting to sleep at night and the timing of shift work that can be negatively and has been shown to be negatively effective on many people. And research just published in Science Advances looked at the question of how does food play into this and the timing of when you eat. So, what time does science say you should eat? In the daytime, according to this study. Yes, we should all be eating in the daytime. And shift workers, apparently, based on this study in which they mismatched, they dysregulated people's schedule and had them exist in a shift work type schedule or a normal schedule, and then had them eat in daytime or at nighttime and measured glucose tolerance, intolerance, insulin levels, these factors, the glycemic control factors that are involved in metabolic dysfunction as a result of shift work. And previous work had really only ever been done in mice. In this, they saw that the people, and it was very small groups, like around 9 and 10 people per group. So this is still very small research study, but the effect was very clear that the individuals who stayed up all night but ate during the day, they had better glycemic control than those individuals who shifted their eating habits to their nighttime waking working hours. And the mechanism behind this, they think, is that we have a central circadian clock that is triggered by light and the melatonin system, but that eating affects peripheral Zeitgebers, the Zeitgebers that when you eat, it triggers and retunes other clocks in your body related to metabolism. So your brain will be on one clock going, this is the day, this is the time, sun comes up, we're just fine. And then you eat something at 3 a.m. and the rest of your body goes, no, we're fine. And so then they're shouting at each other and they don't get along anymore. And you don't want that.
So this is interesting because I will say my personal experience with a shift worker is that he does not eat lunch when he works at night.
Right. That's good.
But he does eat lunch if he's awake during the day. So
is it because you're there and want to eat lunch, or is it because he's hungry?
It's I think it's both. I do think that he doesn't get hungry for food in the same way at night, which might be a response of his body being like, it's nighttime, it's now food time.
Yeah.
That's interesting.
Yeah, so it's an interesting bit of evidence. It's, like I said, small study, but the animal evidence, the cellular evidence, the now humans evidence is accumulating. And yeah, try not to eat at night. It's an easy take-home message. Science says, eat during the daytime. I hope they use this on Jeopardy. Okay. I guess that's it for the first part of the show. Woo! Stories. This is This Week in Science. I do hope that you are enjoying the stories that we bring to you every week. Please head over to twis.org and get yourself a calendar. The TWIS 2022 calendar is available now for you and for your family and friends as gifts. Coming on back for the COVID update. Let's try to get through it quickly because we don't like bad news.
Justin just left.
I know, Justin's like, COVID update, I'm leaving. All right. The Omicron variant that we love to talk about now. It's the new hot variant on the COVID scene. is spreading rapidly around the world, causing concern on the basis of potentially increased transmissibility and immunity-evading mutations. It has been detected now in 19 states in the United States, but Delta is still the dominant variant, while neutralization of Omicron is decreased by 41-fold. This was based on a study of under 20 people, so take that with a grain of salt. In previously infected or vaccinated individuals, protection against severe outcomes does appear to be maintained. So, you're vaccinated for the original variants, you can
Go
still fight
science.
off Delta, and you might not be able to fight off Omicron as well, but maybe you still won't end up in the hospital.
Yeah.
Additionally,
That's winning.
that is winning. Additionally, vaccination after infection and booster does seem to get those immune responses going again, boosting the antibodies that do help with protection against Omicron. So the boosters and infection do continue to give you some protection. It also appears that immunity against Delta gained from infection lasts up to 13 months. A study looked at people who had been just infected with COVID-19, with SARS-CoV-2, and had COVID-19, and how long they seemed to produce antibodies to protect them against the Delta variant, not looking at Omicron, but they saw that the antibody levels from immunity from infection lasted up to about 13 months. So if you got if you caught COVID, now you can get vaccinated now that Omicron's working its way through, and all of those antibodies will be additionally protective. So all of it can work together to help keep you protected.
Yeah, all the antibodies. The
What?
Omicron Persei 8 variant is showing up everywhere very rapidly. So it is ruining Christmas
No, it's
for
not.
everyone. Yeah,
Yeah, it is.
is. Don't go to the mall. Just, you're going to have to, we're going to, we keep talking about like,
Wear your
just
masks.
remember the pandemic. Yeah, okay, you can remember the variant of.
Well, hopefully, a lot of doctors
get used to
and
it.
scientists are thinking that these mutations we're seeing in Omicron, they are still highlighting the fact that the ACE2 receptor is very important for the virus to gain entry into cells. And because of that, that limits the mutational ability of the virus and the ability of the virus to increase its infectivity or virulence, because if it has if the mutations are limited because of that constraint, it's going to be better for us. However, there's a question. What?
Oh, I was gonna say, yeah, you can mutate into a less lethal version.
It could, and this is the thing. This is the thing. And early data for Omicron has scientists and doctors very optimistic that Omicron, even though it's highly transmissible, might not be as virulent or dangerous as previous variants, although it could be a vaccine effect as well. And it could be, a bias effect based on different populations that have been vaccinated and the age groups that are ending up in the hospitals. But right now, evidence from South African hospitals do suggest that fewer individuals are on ventilators or oxygen, and that people have come into the hospital for other reasons, and they're like, oh, I have COVID. I didn't even know. So this is a good thing in a way, but it's too early to celebrate at this point in time. But everybody's crossing their fingers that maybe Omicron is a step in the direction of a little less nasty of a virus.
It's a reminder that a good parasite or a good virus doesn't kill its host.
Right.
So it actually,
so many of us.
It becoming less virulent isn't it doing a bad job. It's actually kind of doing a better job at surviving if it can maintain in the environment without killing its host.
It's this whole being sick for weeks and being able to spread it without dying right away that makes a pandemic. So,
it's that early asymptomatic phase where you're like, I feel fine, and you're like out.
Go breathe on everybody.
That's what I do when I go out in public. I breathe on people.
Pull your mask down
Constantly.
and then breathe on them.
Yeah. Blair,
Yes.
do you want to give us some good news about COVID? Let's do an upswing. Can we do
maybe?
an upswing?
Good news, everyone.
I'm gonna tell you this story, but
Okay.
maybe it's good news.
Maybe.
This is from
Okay.
University of Pennsylvania. It's for a chewing gum that could reduce SARS-CoV-2 transmission.
Okay, I'll take it.
Yeah, so they have made this chewing gum, which is laced with a plant-grown protein that serves as a trap for COVID, which reduces the viral load in saliva, which is often the main method for transmission. And so we know that SARS-CoV-2 replicates in salivary glands. We know that when someone sneezes, coughs, or speaks, or sings, or laughs, or yells, that the virus can be expelled and reach others. We know it's aerosolized, but the droplets definitely have a big punch, right? And so the idea of this gum is that it offers an opportunity to neutralize the virus in the saliva, which cuts down on a major source of transmission. So this was a combination of two things, which is why I think it's interesting. So originally, there were research groups showing that injections of ACE2 could reduce viral load in people with severe infections. Meanwhile, there was another line of research looking at developing a chewing gum infused with plant-grown proteins to disrupt dental plaque. So they took those two pieces of research, combined them, took the ACE2 protein synthesis in plants, and then put that into this gum made out of plants. And so for those two things, then they were able to have this ACE2 from plants in chewing gum that enables the protein to cross mucosal barriers, facilitates binding, and incorporates the plant material all together into a delicious cinnamon-flavored gum tablet. So then they expose saliva. Yeah. So they exposed saliva samples from COVID-19 patients to the ACE2 gum and found that the levels of viral RNA fell so quickly that it was almost undetectable.
Totally not
Amazing.
worth it.
So here's the other thing I'm thinking about is
how many other things?
If you chew gum with a mask on, what happens? The mask will fall off or go up or go down. It's definitely... I don't know if chewing gum is congruent with wearing a mask. So I don't know. That was one of the things I
will let you
about.
know that I chew gum and wear a mask.
Oh, really?
Yeah. It just depends on how aggressively
it makes it smell
you're chewing
nicer.
that gum, Blair. I don't know.
Right.
I don't know how you're going at it. But
Okay.
Gillisator, instead of having masks, we'll have a lot more gum on the sidewalks. Yeah, I don't think it's worth surviving a pandemic if everyone's chewing gum. I think that's a worse outcome than the
that's the other thing.
Percentage of people die.
You know those aerosol graphics where they show how many droplets are exiting your mouth? If you're walking around chewing on gum
smackers.
Maybe that's actually helping to destroy the virus in the air because of the proteins in the gum.
Being operating as a filter.
I don't know. Anyway, the research team is currently working towards obtaining permission to conduct a clinical trial so that they can officially evaluate whether the approach is safe and effective when people are infected with SARS-CoV-2. So you could check into the hospital. They'd be like, oh, you got COVID. Here's some gum.
Have some gum. Treat it with gum.
Listen, it's not going to prevent you from getting sick. And it's not going to get you better if you are sick. But what it would do if you showed up in the hospital with COVID-19 and you could choose this gum, it could reduce the risk of getting people working in the hospital sick, which would be pretty great.
And it's known that nasal saline spray can help rinse out your sinuses and help rinse out viruses that are in there, so that saline rinses can help reduce your chance of getting infected with a respiratory virus. So I'm thinking nasal spray and chewing gum. I mean, that's the drugstore list that I need every
Step 1,
week.
neti pot. Step 2, gum.
Gum.
There you go.
Yes.
Just be sure to use distilled water in your neti pot.
Yes. Yeah, for sure. Don't give yourself brain-eating an amoeba.
Oh yeah, those things
Yeah.
are very
Yeah,
dangerous.
don't want to do that. But I love the aspect of this chewing gum that it's plant-based, that it's plant-derived. There is also a vaccine being produced in Canada by a company called Medicago with GlaxoSmithKline, and they have created a plant-derived virus-like particle vaccine. So the virus-like particles are basically little tiny bits of protein that look like the SARS-CoV-2 virus, and then there's an adjuvant that gets packaged in there also. And then when you get the vaccine, the adjuvant works with those virus-like particles to tell your body, this is what you want to fight off. But they are growing it in tobacco plants. So they're growing it in plants that are being used for the production of other drugs. It's or also potato plants. These plants are consumed by people widely, and plants like potato are very unlikely to produce an allergic reaction in people. So this vaccine, it's thought that it could be safer for a large number of people in its production, and that it works pretty well. It has finished a clinical trial, stage 3 clinical trial, not against Omicron, but this is the first clinical trial with like over 20,000 people that looked at things like Delta variant and the other variants that are out there. And while the early trials had like 90-ish, 95% effectiveness, the effectiveness has gone down to about 70-75% with the newer variants. Don't know what it would be with Omicron, but this vaccine in combination with all the others, or even to boost vaccine supply, is very likely to be a huge benefit. Where'd your vaccine come from? Plants in Canada.
Potatoes.
Yeah.
Taters.
Taters.
I got my potato vaccine and I got a side of fries.
Tater shots?
Tater shots?
Tater shot.
Yeah.
Very good.
I love it.
That sounds like a food you would eat at a party where there's molten cheese in a syringe.
Oh boy. This is This Week in Science. Thank you so much for joining us for another episode. We have more stories yet to come and hope that you're enjoying it. If you are enjoying the show, please share us with a friend today. All right, we're going to come on back right now, and it is time for Blair's Animal Corner.
With Blair.
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels.
What you got, Blair?
I have migratory birds.
How did you keep them?
Oh, I didn't. They ran away.
Oh.
That's what they do, you see. What do all migratory birds have in common?
They are birds.
True.
Mid-Atlantic accent?
They're light-colored. Yes.
What?
This is,
Oh.
Yep.
I would not have,
mhm.
having studied birds, I still would not have put that together.
Yes,
Really?
This is something that is a one-sentence story, but I had to explain it further because it's wild to me. So this is from Max Planck Institute for Ornithology in Germany. And they had this theory, Caspar Delhy had this theory that lighter plumage is selected for in migratory species because it reduces the risk of overheating when exposed to sunshine. So this would be particularly important for long-distance migrants because they can't stop to rest in shade, take a drink, do lots of other things to help temperature regulate. So if they are too hot, they're in big trouble. They can't stop. So this research group had been studying the effects of climate on bird coloration in general. So as temperatures rose, the expectation was that birds would get lighter colored. And in earlier studies, they showed that in general, that lighter colored birds are found where temperatures are high and there is little shade. Around that same time, the researchers came across studies by others that showed that some birds fly at higher altitudes during the day compared to at night, which is a huge cost energetically. To go higher in altitude, there has to be a really good reason to do that, because you're flapping more. You have to, it's way harder than coasting closer to the water. So their kind of guess was that by flying higher where it's colder, that offsets the heat absorbed by plumage when the sun is hot. So the cost benefit analysis, right? It's beneficial to go higher up, even though it takes more energy, because they don't get as hot. And so another way to reduce risk of overheating would be generally to just be lighter colored. And so their general question was, have migratory species evolved lighter feathers? They were able to quantify their plumage lightness from 0 as completely black to 100 completely white for all bird species using bird images from the Handbook of the Birds of the World. And then they compared their data on coloration with the species' migratory behavior. And while doing that, they also controlled for other factors that are known to affect plumage color. So overall, they found that bird species colors get increasingly lighter as they migrate more. This is true on aquatic animals or on land-dwelling migrants. And so similarly, resident birds were darker than short-distance migrants. So there really was this kind of gradient from a super sedentary bird, really dark, super migratory, super light, something in the middle in color as well. Yeah, so the consistence across different types of birds, large and small, geography, all of it, it seemed to really be true around the world. And so what this means is that temperature has a really important role in animal coloration.
Right.
So, of course, this has implications for birds in climate change, potential adaptive evolutionary responses to climate change, identifying future winners and losers in evolutionary pressure. And so they plan to continue to explore the connection between migration, climate, and other factors that shape the evolution of the color of plumage in birds. But yeah, this is something I've never heard before. Kind of makes a lot of sense, but also is surprising.
It is surprising. Yeah. I mean, it's not something that you would just, make that, you wouldn't just notice it because you notice maybe the darker colored birds or you notice different color. I mean, seabirds, yeah, they're lighter colored, but maybe that's because of predation, and maybe that they need to look lighter from the bottom when they're floating on top of the water.
Counter shading.
Yeah. But the impact of the actual temperature and coloration, that's fascinating.
Yeah, which makes sense. You don't want to go to some place that's 90 degrees wearing all black. It's not comfortable.
No, but then if you're gonna hang out someplace where it's cold, maybe you'd want that because then you'd warm up easier.
But if you're running a marathon, even if it's cold, you don't want to be wearing all black.
Okay.
And I think that's the point, right? Is that these birds are putting in such an intense metabolic effort.
Yeah.
That
there's trade-offs that have really influenced. Yeah.
Yeah.
Yep. Yeah. Cool. Okay.
Yeah.
Now I'm going to look at birds and go, you light-colored bird, you must be a migrant. Just remember there's always
there's always exceptions.
And there's outliers.
This is a mathematical model. So this is on the whole, if you kind of like smooth and average out the graph, this is the information that you get. But of course, there's outliers. Speaking of trade-offs.
Do say. Yes.
If you are a male golden orb weaver spider, you have a very difficult trade-off to balance.
You said spiders, so and you said male, so I imagine that we're going somewhere with like the trade-off being the spider's death.
Correct. So if he gets too close to the female too soon, he'll just get eaten.
Mm-hmm.
And that'll be it. If he gets too close to competitors on the web, could also get eaten or killed. So this male orb weaver spider has to perfectly balance a slow orbit around the female to get her attention, but not too fast and not too close, but faster than the other males, but not too close to them, just enough to be able to mate with that female. If he makes one wrong move, he's dinner. So this was a piece of research also from Max Planck Institute, this time from the Institute of Animal Behavior. They looked at spiders for over a decade and wanted to figure out what optimization technique do these male spiders use to know exactly how to approach a female. They have a clump of nerves that's barely a brain. They're not dumb in terms of animals. They do lots of cool things, but are they there doing intense statistical analysis of how close to get to a female? No, they're not. So how do they do this? And specifically, how do they do it with the precision of an orbiting planet around a star?
What?
Yes. So they were able to.
I mean, is the female spider that are these gravitational dynamics that we're dealing with?
Yes.
Here?
Yes. So they're likening gravitational dynamics and the push-pull of an electron around a nucleus, right? As similar to the animal magnetism that is a system of pushes and pulls as these male spiders orbit around the female. They kind of, as a joke, said they looked like electrons orbiting a nucleus or planets orbiting a star. And then the more they looked at it, the more it kind of fit. And so they were able to develop a physical model, and they performed experiments in the Panamanian rainforest on spiders. And so to put it eloquently, as Alex
Please
Jordan did, he said, yeah, I'm not going to do it. He said, quote, imagine electrons orbiting a nucleus or a massive star in space, so large that it generates its own gravitational field pulling in objects around it. The giant cannibalistic female can be thought of in the same way. Now imagine smaller planets, satellites, or comets coming near this attractive force. These are our tiny, brave males. Approach the star or female too rapidly or at the wrong angle, and you risk getting caught up in her attractive pull. On a cosmic scale, this would result in cosmic collision that vaporizes the planet. For the intrepid male, an incorrect approach means falling into a fatal attraction and ending up prey. So they were able to, through these observations, see how overzealous males became dinner and how others were successful. Just as the smaller planets have their own gravitational pull, the males also had their own within each other as they approached rivals. The males started to repel each other as they got closer and closer, behaving much more like electrons around a nucleus. So this is where the kind of the nucleic method comes in. So then the motion of the males resembles interactions between particles that attract or repel each other, depending on the distance between them. So they were able to very loosely, I will say, apply these two models, kind of the planet and the planets around a star for the female, and then the electrons around a nucleus for the males, to demonstrate that the push-pull attractions of these animals and kind of the constant cost-benefit move of like, oh, not too close, oh, but I gotta get close, oh, but not too close, it actually shows that it's not a complex set of decisions that the males are making. They're not sitting there with their pen and paper going like, okay, but if I approach it 90 degrees, right? So they're not doing this. It's actually a very simple dynamic force that is played out in other places in nature. And so this is a way of explaining this extremely complex behavior without quote unquote complex cognitive machinery.
Got it. Right.
I
You
don't
don't
get
need
it.
a big brain to do all this, but there are these little pieces that add up
It's
very precisely.
It's also kind of like it's like the Roomba sensing the wall and moving away from it before it touches it, right? So that's basically what's happening is there's all these spiders that are like their own little Roombas that they're like, oh, too close, push back. Okay, let me try to get this, but oh, too close, push back. So it's basically a constant reaction to the movements of these other spiders on the web in a way that looks very deliberate, but really is just the dynamics of these different things moving in concert and responding to each other in real time.
It is the emergence of order from a complex system.
Order from chaos.
Yes. Yes, it is. Justin, do you want to talk about science now?
Tanzania, on the east coast of the African continent, home to many of the world's mightiest beasts. The elephant, the lion, the leopard, the buffalo, the rhino, and the bear. Also has the oldest evidence of upright walking hominins ever discovered. It's at the Laetoli in Tanzania in 1978. Paleontologist Mary Leakey, may have heard of that name before, and her team found 2 sets of fossilized footprints that date to 3.7 million years ago and are thought to be Australopithecus afarensis, the species of the famous Lucy skeleton. So they got footprints. They got a couple of tracks of these footprints out there, and they go, oh, great, we can see 3.7 million years ago upright walking. There's another set of footprints, partially excavated in a nearby site. It was actually found a little earlier than that, a few years before. That was dismissed because it was bears. It was bears walking on bipedally, apparently. Recent re-excavation of those footprints are reported in the journal Nature and revealed that the footprints were not made by bears.
Ooh.
They were made also by bipedal hominins. However, not Australopithecus afarensis. Dun, dun, dun. So, yeah, they had some fun here. This is given the increasing evidence for locomotor species diversity in the hominin fossil record over the past 30 years, these unusual prints deserved another look, says lead author Ellison McNutt, assistant professor at Heritage College of Osteopathic Medicine at Ohio University, and the second McNutt that I'm reporting on in this same show, which is very interesting. To determine, so they did all this fun stuff. So they had these bears that are in a rescue park, and they lured them with treats on sticks, basically, and got them to walk over mud, so that they could check out what a black bear footprint might look like. They also did the observations of black bears in the wild and found they only walked on their back feet less than 1% of the time. So it was very unlikely that the footprints that they found in Laetoli, especially since there are no 4 footprints in the ground at any given time, the individual only is on the 2 legs. Unlikely the bear. They studied some chimpanzees at a sanctuary in Uganda. Again, one of the discoveries they made is the heels for both bears and chimpanzees tend to be rather thin compared to the footprints that are found in Laetoli. Also, there's a large toe and a large second toe next to it, which also kind of nailed it down as to being human. And comparing these footprints, though, to the morphology and the gait that they would expect from the Australopithecus afarensis, they said, no, it's distinct. It's a different foot. It's a different gait. This is some other hominin walking around.
But we don't know who.
Don't know who. Don't know
Just
who this
some
one is.
other.
Yeah.
But we know there's a lot of variation within a species, so it could have been, could it have been an Australopithecus that was hopping or playing around that had a lame leg? Or
Yeah, so sort of
mean-
also part of one. I guess some of this footprint also involves a crossing over step that is almost as though someone were losing balance, or like an off balance step where you're recovering balance almost.
maybe they
So
were carrying something and tripped,
yeah,
or
could be, could be. But also very unbear-like in the
Yeah.
narrowness of the stances. Bears also tend to be much wider. But it's very interesting that in 1976, this got dismissed as bear. And then here we are, I don't know how many years that is, 40-something years later. We're like, oh no, we just discovered a possibly new hominin in these footprints that we didn't know was walking around.
Well,
Back
we
in the
thought brontosauruses were real then too.
They are.
Right. We've learned so much.
They are. They got brought back. Haven't you heard? There's Brontosaurus is a dinosaur now.
Gigantosaurs, the saurosaurs.
I'm gonna finish where I
Brontosaurus.
started.
Finish
You can
it.
only go so far in this world before you find yourself at a door. You unlock that door with the key of education. But what if you don't happen to have a key on you? What do you do then? Prison. That's what. We've all been there, staring at the walls of our cell, wondering, how
What?
the heck did I wind up here?
We have?
More importantly, perhaps,
We all have? What?
how can I keep from coming back?
Yeah. Okay.
New study. Yeah, everybody's been to prison a couple times. Come on, who are we kidding? New study looked at the effects of college in a prison program called the Bard Prison Initiative, BPI, Bard Prison Initiative. Study found a large and significant reduction in recidivism. Recidivism is the rates at which people who have gone to jail or prison and been released end back up again. Go back to prison. Make more choices that led them to get arrested again. Study by researchers at Yale University, as well as folks working at BPI, appears in Justice Quarterly, a publication of the Academy of Criminal Justice Sciences. This is quoting Matthew G.T. Denny, PhD student at Yale University, co-authored the study. Incarceration is bound with systems of poverty and a lack of access to opportunity, especially education and socioeconomic mobility. Participation and intensity of engagement in programs like BPI might disrupt these cycles. So there's a somewhat of a history of the federal government backing prison education. Beginning back in 1965, people who were incarcerated in the United States were eligible for Pell Grants from the federal government to receive funds to attend college, even though that they are incarcerated. So you have then jailhouse education programs, colleges show up to educate these people who could spend the money, yada yada, thanks to federal government. 1994, Clinton administration, part of their 356-page Violent Crime in Law Enforcement Act, had one of the provisions which banned incarcerated students from receiving Pell Grants, effectively shutting down college in prison programs, especially for lower income inmates. Kind of hard to understand what exactly they expected the outcome of making sure that people who were incarcerated for some period of time left incarceration with the same level of education with which they entered incarceration in the first place.
It was just a recipe for the spiral to the bottom.
Mm-hmm. Yeah,
it's not helping anybody. Yeah.
So mid 90s, Clinton administration wants to look tough on crime. They ban assault rifles. They spend a bunch of money on putting more police on the road. They dedicate money to combating violence against women, and they take textbooks away from imprisoned students because that last one was really needed to happen. 2016, Obama administration started Second Chance Pell Pilot Program. Federal aid once again is being offered to select colleges within the prison program systems. This study, though, looked at the largest and most rigorous, was the largest and most rigorous to date on the effects of college and prison programs on recidivism. The program they looked at actually has weathered some of this storm of Pell Grant being there or not. They've been had this prison program in place, a prison college program in place since 1999, and they are operating campuses in 6 New York correctional facilities. They found that the study found that participation reduced recidivism by 38%. Greater levels of participation correlated closely with even lower rates of recidivism. So that's a huge number. Returning to prison occurs within a year for nearly half of people who are released from prison. Nearly half. I think it's 40. Yeah, it's 40-something percent. Released from prison, end up back in prison within a year. That's staggering. Within 9 years, it's about 83%.
Yeah, it's too much. It's here in the United States. It is a system that is meant. It's a profit-making system for the prison industrial complex. It is a way to keep people in their place, and if we really wanted to benefit society, prison education systems would be well funded. They would be we would be trying to help people graduate from college while they are in prison.
Teach them a trade while they're in prison.
Also, re-education
if
on
they
so
fight
many
fires
things.
while they're in prison, allow them to actually be firefighters when they leave.
That's smart. So a few things here. One, since education and opportunity are factors in how people wind up in prison in the first place, maybe focusing on those things in the first place might avoid needing to support the world's largest prison population industry for America. 2, why wouldn't we want a system that rehabilitates people and gives them those opportunities when they leave to make other choices on the outside? Right?
Maybe through science and scientific evidence, we can benefit our society enough that we can make better choices that really work for us in the long run. Okay, I have a couple of quick stories related to blood and proteins and things that we love to help us. We would love to have them help us live longer, better, stronger lives. One paper was just published in Nature Aging, and this paper in Nature Aging out of the University of Pittsburgh has pinpointed that there are little transcripts, little bits of a protein called Klotho that has been indicated previously as being beneficial in the longevity process, making aging not happen as quickly, rejuvenating aged individuals, that Klotho can have a very beneficial effect. And in this particular case, these researchers were looking at muscle wasting. And as people age, it gets harder and harder for their muscles to rebuild themselves. You have increased scarring and weakness, and someday you're just weak. I don't want to get weak. I want to stay strong. So this really makes me happy. These researchers discovered that the blood contains extracellular vesicles. And this is not, beam me up Scotty talking about the vessels. This is extracellular vesicles, and they contain Klotho. And in younger individuals, you have lots and lots of Klotho in lots and lots of extracellular vesicles. And all that Klotho, those vesicles, they link to and they merge with the cells of the myofibers, and the myofibers, they like the Klotho transcripts, and the Klotho transcripts like to help the muscles grow and regenerate. So young muscles can regenerate better, have reduced scarring, are nice and strong. As you get older, fewer vesicles in the blood. less Klotho in the vesicles. And they have discovered that if they take, of course, the vesicles from the young blood and give the vesicles to the older blood, then the older blood can begin to rejuvenate the muscles like the younger blood, like the younger muscles once did. So we maybe will not have to go ahead with the drinking the blood of the young to maintain our muscle strength. Hopefully understanding that proteins like Klotho and the little bits and pieces of the protein that the muscles respond to, that maybe we can use those and their receptors as targets for muscular regeneration, anti-muscle wasting drugs, and treatments as we get older. One aspect of this work. Oh no, this is the next study is something also very interesting. Moving away from the Klotho. So Blair, these are proteins that you need to remember to look for in the mix that you're going to be drinking.
But how will I remember them if I haven't been taking them?
You will exercise, and the exercise will help keep you young long enough to remember that you need to start taking them before you get too old. Yes. Okay. So the other protein is called clusterin.
Klotho and clusterin? Stop.
Klotho and clusterin.
That's not real.
Yes. Everybody's clusterin. Whoop.
Yes, I would like the Klotho clusterin immortality pills, please.
Yes, please. Stanford researchers published in Nature today on their work looking at clusterin in mice. Now, they determined that mice that exercise produce a lot of clusterin. And then when they took the clusterin from the exercise mice and gave it to lazy sedentary mice, well, they just weren't allowed to exercise. The sedentary mice suddenly were smart like the exercise mice. And so the benefits of exercise to cognition were passed along by there's a whole bunch of anti-inflammatory markers that are in the blood from these young adult fit mice. Clusterin was the one that seemed to be the most important in the transfer of the abilities of the cognitive benefits to the sedentary mice. And the big thing that I thought was really interesting about this study is that not only were the sedentary mice getting smarter, they looked at the blood of veterans who had been on a multi-day, these are military veterans that had mild cognitive impairment, 6-month aerobic exercise program. At the end of this 6-month aerobic exercise program, these veterans had elevated clusterin in their blood. So, exercise potentially is connected to increases in clusterin. Clusterin is anti-inflammatory. It also gets past the blood-brain barrier and potentially has cognitive benefits. They did not say in this study whether or not they had been able to link the increase in clusterin to cognitive improvement in these individuals with mild cognitive impairment. That hadn't been done yet.
Ladies and gentlemen, exercise in a pill. Getting sweaty at the gym, breathing the air, and delving into the sweat of all those strangers is now a thing of the past. You can now pop a pill and get all the benefits of somebody who exercised a lot without having to do any of it.
I was thinking more, if I exercise and take the clusterin, will I get younger?
Ooh, can you get more benefit?
Be younger.
Moderation.
Yeah, moderation.
Abusing the drug, right? Look, there's a new drug. I want to abuse it. Can I?
What, all of it?
First instinct.
You can't have too much of a good thing. It's science.
Oh, yeah, even then.
Yeah. It is science, but it's fascinating that we're beginning to be able to dial in some of these factors that are involved in in aging and by understanding not only the factors so that, okay, maybe we can, yes, create an anti-aging pill or a, a cocktail of things that you're able to take. But for people, but especially for people who are bedridden, who are sedentary, who are unable to do movements and exercises that would be beneficial. But for people who are, excuse me, able to move, able to get out, able to have exercise, and that this is not like, professional athlete level exercise they're talking about. I mean, it's movement. It's getting your body moving and your heart rate up for periods of time. Yeah, that natural movement that our body, that it's good for our body to move. And there are some really interesting hypotheses out there about how it all feeds in together to have healthier aging, reduce inflammation, live long and prosper.
Yeah.
With Klotho and clusterin.
Name my first two children, Klotho and clusterin.
Oh, well, I'm going to say that I think we've done it.
Come to the end of another show?
We have. I did want to say, did get a letter from Scott Rhodes. Says, this may have already been addressed since I'm an episode behind, but I was listening to the story about vulture bees, and as a beekeeper wanted to clarify something. Pollen and apparently meat provide a protein source for bees, but the honey is made from nectar. While some pollen makes its way into honey in minute amounts, because it's on the bees themselves, it's stored in separate chambers than the honey and is not used directly for honey. Love the podcast. But I do need to say, I looked it up, and vulture bees actually produce honey. It's not honey. It's a honey-like substance.
Correct.
Not derived from nectar, but from protein-rich secretions of the hypopharyngeal glands.
Yes, it's still bee barf, and it comes from the meat. I did additional research after this show as well, because I was also very interested in that idea of where this honey comes from. And yes, you would think that they need to get to nectar to make it, but they don't.
The vulture bees do not. These vulture bees are fascinating. And I also want to say thank you very much to those of you who did write in related to last episode's disclaimer. And there were some positive comments and some educating comments, and I am taking them all in and appreciate them all very, very much. And thank everybody. Thank you for listening. I hope you did enjoy the show. I hope you enjoyed every little bit of it. I would like to say thank you to Fada for your help with social media, for show notes. Gord, thank you for manning the chat room, keeping things clean. Identity 4 for recording the show. Thank you so much. Rachel, for your amazing assistance and helping with editing. And I would like to thank our Patreon sponsors. Thank you to Richard Badge, Kent Northcote, Pierre Valazar, Ralphie Figueroa, John Ratnaswamy, Carl Kornfeld, Karen Tazi, Woody MS, Andre Bassett, Chris Wozniak, Dave Bunn, Vegard, Chefstad, Hal Snyder, Donathan Stiles, a.k.a. Don Stylo, John Lee, Ali Coffin, Maddie Perrin, Gaurav Sharma, Don Mundus, Stephen Albaran, Daryl Myshak, Stupal and Andrew Swanson, Fredis Winnesor, Sky Luke, Paul Rodovich, Kevin Reardon, Noodles, Jack Brian Carrington, Matt Bass, Sean and Nina Lamb, John McKee, Greg Riley, Mark Hessenflow, Gene Tellier, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Dana Pearson, Richard, Brendan Minish, Johnny Rigidley, Kevin Railsback, Rami Dave, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Hey Arizona, support Aaron Lieberman for governor, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Mallory Sutter, Philip Shane, Kurt Larson, Craig Landon, Mountain Sloth, Jim Drapeau, Sarah Chavez, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E.O. Kevin Parachan, Steve DeBell, Bob Calder, Marjorie, Paul Disney, David Summerly, Patrick Pecoraro, and Tony Steele, Ulysses Adkins, and Jason Roberts. I can't read anymore.
Wow.
Thank you for all of your support on Patreon. And if you would like to support TWIS on Patreon, please head over to twis.org and click on the Patreon button on next week's show.
We will be back Wednesday, 8 p.m. Pacific Time, Thursday, 5 a.m. Central European Time, broadcasting live from our YouTube, Facebook channels, and from twis.org/live.
Hey, do you want to listen to us as a podcast? Maybe while you make some delicious baked goods with your vulture bee meat honey? Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, get your friends to subscribe as well.
For more information on anything you've heard here, show notes and links to stories will be available on our website, www.twis.org, and you can also sign up for our newsletter.
You can also contact us directly. Email Kirsten at kirsten@thisweekinscience.com, Justin at twisminion@gmail.com, or me, Blair, at blairbaz@twis.org. Just be sure to put TWIS, TWIS, in the subject line, or your email will be spam filtered into my evening's Klotho and clusterin cocktail.
It's going to last a while.
You can also ping us up on the Twitter, where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you'd like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world, so I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice, show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand, and all it'll cost you is a couple of grand. 'Cause this week's science is coming your way, so everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in